Alright, in this lesson we're going to take a look at factoring perfect square trinomials. And what we're looking at here on this slide, you see these first two equations. These are actually formulas that we're going to be using. And we're looking at this problem here, the p squared minus 16p plus 64. This is something that previously we were able to factor using the magic x, and you can still do that using the 64 on top and the negative 16 on the bottom, and you would get negative 8 and negative 8. And you would end up putting those over a p and getting p minus 8 times p minus 8. Now, because there's two of the same thing, we can actually rewrite this to be p minus 8 squared. Okay. Now this is a special problem because it's a perfect square after you factor. And this is in a form of these equations that I have at the top of the page. And because it's in this particular form, we can use these equations in order to quickly factor and go straight to the answer without actually having to do any magic x factoring work. In other words, I'll be able to take this equation, notice what it is, and say, oh, it's just p minus 8 squared. And so that's my hope, is to actually get you to be able to recognize that by the end of this lesson. And I do that because, and I can do that because I notice that this number in front is a square. In other words, it has a nice perfect square root. The square root of p squared is p. 64 has a nice clean square root. Square root of 64 is 8. So all I have to do is look at this number in the middle. Okay? The number in the middle is the bridge that tells you whether or not this is a perfect square trinomial. And I look at these formulas over here, and if you notice it takes the 2, don't worry about the negative sign, and it multiplies the number in front times the number in the back. So 2 times the number in front times the number in back. Same thing on this other formula over here. The only difference is it's a plus sign. And that only makes the answer at the end plus or minus based on what this sign is here in the middle. So backing up, don't worry about the plus or minus sign just yet. All I have to do is think about, is this negative 16p really just 2 times the first number, which is 1p, times the last number, which is 8? In other words, is 2 times 8 16? And it is. So this follows this formula on the top left hand side, which means all I have to do, since it follows the form of being 2 times the first number times the last number, is that I can use this form to jump straight to the answer of saying, alright, well, this is equal to the first number, which is just p, minus the last number. And by the number I mean the square root of each of those numbers, squared. And that's your answer. No more work involved, don't have to do the magic x. So please bear with us and follow this. I know we can go back to the magic x, but you'll see why this is easier to do in subsequent problems. So check out this problem here. So I'm looking at this number in front and square rooting it, 2x. And take this number in back and square root it, 5. Okay. Now you're looking at the number in the middle, which again, that's the bridge to tell you whether or not you can use this formulas. Now notice I'm not going to use the one on the left hand side because it's got a minus sign. I'm using the one that has a plus sign for my problem because this has a plus sign. And it just makes a difference in your final answer. So I just check out, is 20x 2 times the first number, 2x, times the last number, 5. And so all I have to do is multiply. 2 times 2 is 4, times 5, that is in fact 20. So this works in this form. So all I have to do is say this is equal to the first number, which was 2x, the square root of the first number, and the plus the square root of the second number, which is 5, parentheses squared. Done. I don't have to do magic x, I don't have to factor anything. That's your answer. So you can see it is a quicker method if you can follow and understand here. So now I move the formulas up here, get them out of the way a little bit more. You can see that this problem is just bigger, but it's the same thing. 144x squared has a square root of 12x. 25 has a square root of 5. Now we just look at the bridge. Does this make sense? I've got 2 times 12x times 5. Well, 2 times 12 is 24. 24 times 5 is 120x. So this does, in fact, work. And so all I have to do is realize this is a minus sign, which means I'm using the minus formula, which means my answer has the first number, which is 12x, and then minus the second number, 5. I'm sorry, I missed the x there, 12x, minus 5 squared. And that's the final outcome for this particular problem. Now on this problem you can see where it actually gets a little bit more complicated and where we really do actually want to use this formula rather than try to do magic x, because it doesn't seem to make much sense to do magic x with this particular problem. So we still work through the form that we were using a minute ago, which is we just take the square root of this first number. R plus 5 parentheses squared is actually a number that I square root, and it just, when I square root it, it knocks off the square root sign, square sign. So this just turns into r plus 5 if I square root it. And then this 9, you can square root that, and that gives you 3. So the question is this number in the middle, this 6r plus 5, the outcome of 2 times the r plus 5 times the 3. And you can see if you multiply the 2 times the 3, you'll end up getting the 6 and then the r plus 5. So it is in fact in the correct form. The plus sign means I'm using the first formula. And so all I have to do is write the first number, which in this case is r plus 5, I'll leave it in parentheses, plus the second number, square rooted, which is 3, squared, and that is your answer. Now I do actually want to reduce the answer a little bit more, because the r plus 5 doesn't actually need to be in parentheses. It's really just r plus 5 plus 3 squared, which means your answer is actually r plus 8 squared. Okay? So this is, again, a much quicker method than using magic x, as long as you can follow square root the first number, square root the last number. So in our final example here, we see one where it's got a variable in front and a variable in back. So we still square root both of them. Square root of 4m squared is 2m. The square root of 49n squared is 7n. So now we check the gap here, and we've got 2 times the first number of 2m times the last number of 7n. And if we multiply that together, you see 2 times 2 is 4. 4 times 7 is 28, and I'm sorry, this number in the middle is supposed to be 28, not 20. So it does work if that number was what it was supposed to be, which was 28. Sorry that happened, a little mistake there. And now that we have that, I can jump straight to the answer that says the first number, 2m, plus the last number, which is 7n squared. So it does work if in fact the problem was written correctly with the 28. But you can see how it doesn't take much time. Even with two variables, this moves very quickly. All right.